Hello students. So after completing 6 problems, let's start with the next problem of composite function. So here I have a function for which we have to derive the given result. But this time guys, it's not so easy to get the answer by just partial differentiation. So here I'm gonna use one more property which will state the relationship between complete differentiation and partial differentiation. So we'll use that property to solve this problem. So here u is given as x square plus y square plus z square minus 2xyz is equal to 1. Now guys, we have to prove that dx by root of 1 minus x square plus dy by root of 1 minus y square plus dz by root of 1 minus z square equal to 0. Now the question is, if we have to prove this result, then in this result we are not finding any partial differentiation, because here we have the terms like dx, dy and dz. That is one thing. The second thing is, if here in the question it is given that u is a function of x, y, z, then we should differentiate u with respect to x, y and z. But in the whole question, or I mean in the whole result, there is no term which is differentiating u with respect to x, y and z, because here we have dx, dy, dz. Now the question is how to get the solution. So guys, since here u is a function of x, y, z, and in the result we can see the terms dx, dy and dz, here we are going to use the property where there is a relationship between the partial differentiation and the complete differentiation. So for that, what we'll do, we'll take all the terms on left hand side and we'll make right hand side 0. So here first of all I'll say u is equal to x square plus y square plus z square minus 2xyz minus 1 equal to 0. So it means we got u equal to 0. So if I find the derivative of u, we will get du is equal to 0. So now what is the formula for du? So du is nothing but it's a differentiation of u. So if I want to represent this differentiation term in terms of partial differentiation, then by chain rule it is given as del u by del x into dx plus del u by del y into dy plus del u by del z into dz, and this equal to 0 as it is. So it means this is the formula for this du. So you can see that I've represented du in terms of partial differentiation term. Now guys, you must be thinking how we got this term. So there are two ways to prove this. Do one thing, like let's say this is a function. So what you can do is you can differentiate this function, let's say with respect to x. So you will get value of du by dx. So keep that value with you and say it as equation number 1. Next, here in these values you find out del u by del x, you put del u by del y here and del u by del z here and put this value here, and then you'll observe that both the values are same. So that is a one way to prove. The second way is I got this relationship from the tree diagram. Now how? Let's see. So let's say that u is a function of x, y and z, and for time being let's say that this x, y and z all are function of t. So it means I can say that u is a function of t and x, y and z are the intermediate variables. Now guys, if I ask you to apply the chain rule to this tree diagram, then here I'll write down that it will be du by dt equal to, now why I'm saying du by dt, it's simple, because u is a function of t, there is no other variable present. That is why when I'll find the derivative, I will not get partial differentiation, I'll always get a complete differentiation. So du by dt is equal to del u by del x into dx by dt. So that is the first part, this one. Then plus del u by del y into dy by dt plus del u by del z into dz by dt. So you can observe that I'm taking first term as a partial differential, because when I'll differentiate u with respect to z, we can keep y and z as constant. But when we'll differentiate z with respect to t, there is no other variable or other independent variable present, and that is why we'll get the complete differentiation. Now guys, let's say this is a relationship I'm getting if I consider u as a function of t and x, y, z as an intermediate variable. Now it's simple. Just eliminate this dt term from both sides. So if I eliminate this dt, because as I said, as I've assumed that u is a function of t, tomorrow I may assume that u is a function of q, correct? So it means this variable which I have taken here is just a temporary variable. So what we'll do is we'll remove that t, because if tomorrow here we get q, so we'll get du by dq. So everywhere we'll get dq, dq, dq. It means this term will change, but remaining result is gonna remain same if I change this variable. So let's remove this. So if I remove this dt from both sides, then you can observe that, guys, I got a relationship which I have written exactly here. So the value of du is del u by del x into dx plus del u by del y into dy plus del u by del z into dz. The same result I got here. So guys, this is how we get this result. Now it's simple. To get this answer, you can observe that dx, dy, dz, all three terms I got. Now I just have to find out del u by del x, del u by del y, and del u by del z. So let's differentiate u with respect to x, then y and z partially. So if I differentiate u with respect to x partially, here we'll get 2x and here we'll get negative 2yz. So therefore we'll write down the result directly. So in place of del u by del x, I'll write 2x minus 2yz into dx plus, now in place of del u by del y, I'll write here I'll get 2y and here I'll get negative 2xz. So here I'll write 2y minus 2xz. Next, here del u by del z, so we'll get 2z minus 2xy. So this is dy as it is. So here I'll say plus 2z minus 2xy dz, and right hand side is 0. So I've written. So guys, we got this result. Now if you observe, then we want this result. It means in this result, in the numerator the coefficient is 1, but in the denominator we want square root term. Now the question is how to bring square root term. So let's consider this first term only. So with dx we want 1 upon square root of 1 minus x square. Now let's see how to bring that. So here, okay, before that what we'll do is we'll take all these two common, we'll send it on the RHS, so that we'll get only x minus yz, here y minus xz and z minus xy. Now as I told you that we'll consider this first term, so what I'll do is from this first term I'll try to bring this 1 upon root of 1 minus x square. So here we have a value of x minus yz. So guys, what we'll do is I will consider this given result. So this given result is, or the given term is, here I'll write therefore x square plus y square. Now guys, here as we want the substitution for this x minus yz, what I'll do is I will keep few terms on the left hand side. Like here I'll keep x square and I'll keep negative 2xyz on left hand side. Now what I'll do is I'll shift remaining terms on the right hand side. So here I'm purposely keeping some place because I want to add some term. So 1 will go there, will become positive 1. This y square will become negative y square and negative z square. Now guys, let's say if I want to make this term as a complete square term, using the formula a minus b the whole square, here I have to add y square z square, because by doing that here we can get x minus yz the whole square, which will exactly match with this x minus yz. Now since I'm adding y square z square, to make this term as a complete square I have to add this y square z square on RHS as well. So here I'll get plus y square z square. Now from first two terms we'll get 1 minus y square. From last two terms we'll get negative z square common. So in bracket we'll get 1 minus y square. So it means this is 1 minus y square into 1 minus z square. Now here we got the substitution for this x minus yz the whole square. Now guys, if I take square root on both sides, we will get the value of x minus yz as root of 1 minus y square into square root of 1 minus z square. So we got this substitution for x minus yz. So similar substitution if I do for remaining terms. So here we have y minus xz and we have z minus xy. So guys, now you have to perform the same process for this y minus xz and z minus xy. So I will write whatever is the answer directly because it is going to follow the same procedure. So here we'll say that the value of y minus xz is equal to, it is square root of 1 minus x square into square root of 1 minus z square. Now similarly, we'll find out the value for z minus xy. So z minus xy will give us square root of 1 minus x square into square root of 1 minus y square. So guys, we'll get these three values. Now what we'll do is, we'll substitute these three values here and we'll rewrite this result. So I'll say therefore so we got this result. Now to get the final answer, let's observe that. So in the final answer we want coefficient of dx as 1 upon square root of 1 minus x square. Now guys, to get this value, what we'll do is, we'll divide these three terms, all three terms, with square root of 1 minus x square, square root of 1 minus y square and square root of 1 minus z square. So we'll divide throughout or the both side with square root of 1 minus x square into square root of 1 minus y square into square root of 1 minus z square. So by doing that, what will happen, two terms will cancel from the numerator, and in the numerator we will get 1, and in the denominator one term will remain because we are dividing with three terms. So here these two terms are of y and z. It means in the denominator the term of x will remain. So guys, that is nothing but your answer. Similarly, in the second term, you will cancel x and z term, so that in the denominator y term will remain, and from last you will cancel x and y term, so you will get z term in the denominator. So here I'll write guys here, therefore by doing this you will get your final result. So it means we'll get this answer. So I'm sure that you understood the solution of this question and how I derived this result. So just apply the same strategy, same logic in the examination and get good marks. And guys, also don't forget to subscribe to Ekeeda channel, and don't forget to share this channel with your friends, because they can also get benefited by the lectures given by me and the other professors of Ekeeda. Thank you very much.